Operation Refurb is a 4-part program that provides the warfighter with the tools to maintain and repair mission-critical communications in the warehouse, the depot, or the theater. Each phase of Operation Refurb enables the warfighter to locate and repair breaks or sustain optical fiber cables and connectors. The Operation Pinpoint Kit is used to locate breaks or bends in optical fiber cables and diagnose connectivity issues. The Operation Pigtail Kit is used to repair cable breaks or replace connectors in minutes and protect the repairs against future damage. The Operation Clean and Polish Kit is used to ensure TFOCA 2 connectors are in good operating condition before they are restored to service. And the Operation Test and Verify Kit is used to measure the insertion loss of fiber optic connectors and restore them to operational readiness. Let's look at each kit more closely. The Operation Pinpoint Kit allows you to locate cable breaks or excessive bends to within 1 foot over many kilometers of cable. All the tools and parts you will need are in the 0831 TAC 8245 kit. The kit features an optical time domain reflectometer or OTDR for testing cables, a power meter, and laser and LED light sources for testing insertion loss at connectors. All necessary high-quality launch cables, or HQLCs, to interface with the OTDR. All necessary high-quality reference cables, or HQRCs, to interface with the light sources and power meter. A visual inspection microscope with adapters. And cleaning supplies for connector ends. To perform the reflectometry test, identify and select the HQLCs that will be used based on the cable being tested. Before performing any test, inspect and clean the HQLCs that will be used in the test, as well as the OTDR module port that will be used. Inspect and clean all interfaces before connecting cables. Connect the HQLC to the appropriate test port on the OTDR module. Connect multimode cable to the MM port under the orange cover. Connect single mode cable to the SM port under the gray cover. Connect the other end of the HQLC to the cable under test. Press the Home button on the tester to display the home screen. For testing multimode fiber, touch the Expert OTDR soft key labeled MM. For testing single mode fiber, touch the unlabeled Expert OTDR soft key on the bottom row. Press the Setup key to access the setup screen. If the Acquisition Setup box is not displayed on the setup screen, touch the Acquisition soft button. Use the arrow key on the tester to scroll through the Acquisition menu and confirm the acquisition settings for the test you are performing. To load a previously stored setup configuration or to manually set up a configuration, refer to the OTDR Operator's Manual. Touch the Top Menu soft key to return to the top menu, then touch the Alarm soft key to inspect the alarm settings. Touch the Analysis soft key to inspect the analysis parameters. Touch the Link soft key to provide naming conventions when storing fiber traces. And touch the File soft key to set up file storage parameters. Refer to the OTDR Operator's Manual to adjust any settings. Once the parameters have been confirmed, press the Results button to bring up the results screen. Press the Start/Stop button to start the acquisition. The red light on the tester will illuminate to indicate testing is underway. The acquisition bar at the bottom of the screen will show the elapsed and remaining time. When the measurement is complete, the tester will beep and display the trace. Each spike on the trace indicates a connection between two cables or an anomaly along the length of the cable. This display demonstrates a test of two cables connected together for a total distance of 50.668 kilometers. You can see the connector and the end of the second cable and the length of each from the insertion point. To use the light sources and power meter to test insertion loss, refer to the Operation Test and Verify instructions. The Operation Pigtail Kit allows you to repair broken fiber cables or cut off bad connectors and replace them with pre-built and pre-polished pigtails. All the tools and parts you will need are in the 0831 TAC 1119 kit. The kit allows you to keep the quad fusion splicer in the ruggedized transit case while you work, minimizing the setup and cleanup time. The attached V-groove clips allow you to position the jacketed cable so the fibers can be aligned in the fusion splicer without strain. Always follow good fiber optic safety procedures while performing splice operations. The following procedures are used for cable repair and connector replacement. These first steps are essential and must be followed before splicing. Open the operation pigtail case and lift out the upper layer of foam to reveal the armored enclosure. Take out the enclosure and set it aside, then replace the upper layer of foam. Unscrew the entire cap assembly at each end of the enclosure and remove the washer, cone, and cup from each end. Feed one cable end through a cap assembly starting from the outside and push the cap down the cable out of the way. Next, feed the washer, then the cup, onto the cable. Ensure the tapered end of the cup is facing the end of the cable once it is installed. Feed the cable end through the enclosure and pull at least 18 inches of cable through the enclosure. Feed the remaining washer and cup onto the other cable end to be spliced. Ensure the tapered end of the cup is facing the end of the cable once it is installed. Prepare the thermal stripper for use by selecting it from the kit and turning it on to allow it to heat up. Remove the clear plastic cap from the cleaning solution and use it to collect waste buffer, Kevlar, and fiber for proper disposal. Lay one cable end on the ruler in the case, with the end at the 6.5 inch mark. Use the included silver marker to make a mark on the cable at the 0 mark on the ruler. Repeat this step for the opposite cable end. Use the included cable jacket stripper to slice the cable jacket between the mark and the end of each cable. Carefully peel the halves of the cable jacket apart, leaving the Kevlar strength members together. Use the scissors in the kit to cut off the loose cable jacket half and discard the jacket section. Remove the remaining cable jacket half, again keeping the Kevlar strength members together around the fibers. Cut this cable jacket section off with the scissors. Carefully separate the strands of the Kevlar into 2 equal halves, ensuring that all of the Kevlar fibers are clear of the colored communication fibers. Pull the Kevlar fibers down against the cable jacket and trim off any stray fibers. Place the metal cone from the armored enclosure, narrow end first, onto the 4 communication fibers. Bring the Kevlar fibers together and pull them straight out from the cable jacket. Twist them together and feed them through the cone alongside the communication fibers. Slide the cone down toward the cable jacket and ensure the cone is seated around the cable jacket. Spread the Kevlar fibers into 2 equal halves and pull them down on opposite sides of the cable jacket. Make sure they are not tangled with the communication fibers. Spread the Kevlar fibers evenly around the wide end of the cone. Hold the Kevlar fibers in place at the narrow end of the cone while twisting the ends of the fibers. Cut off all but 1.5 inches of the Kevlar fibers. Gather the Kevlar fibers tightly against the cable jacket and slide the cup over the fibers and as far onto the cone as possible. Use the slip jaw pliers from the kit to press the cup as far onto the cone as it will go. Cut half of the Kevlar fiber tail off. Repeat the previous steps for the other fiber end to be spliced. Slide a glass protection sleeve onto the 4 communication fibers on one of the cables and push it back to the Kevlar. Select a quad fiber holder from the kit and align the fibers in the 4 channels, so 1.25 inches of fibers extends from the end of the holder. Close the magnetic cover to clamp the fibers in place. Place the fiber holder in the fixed end of the thermal stripper, allowing the fibers to extend into the movable chamber. Align the fibers in the channels of the thermal stripper and close the lids on both parts of the device. When the green pilot light burns steadily, hold the lids closed and pull the two sections of the thermal stripper apart. The colored buffer will be stripped from all 4 fibers at once, leaving a residue behind on the fibers. Moisten a lint-free wipe with the included cleaning solution and gently wipe the residue from the fibers until they are clean. Always pull the wipe from the buffer to the end of the fiber. Open the cleaver and install the holder in the cleaver, holding it firmly in place. Press down on the cleaver to create an even cleave across all 4 fibers. Open the fusion splicer and place the fiber holder on one side of the splicing chamber. Repeat the preceding steps to prepare the opposite cable end for splicing. Ensure the colored buffers are matched to the buffers in the opposite fiber holder. When both cable ends have been placed in the fusion splicer, close the splicer and start the splicing operation. When the splice is complete, open the splicer and carefully remove the spliced section from the splicer. Slide the glass protective sleeve over the splice and place the sleeve in the oven. Press the sleeve in the oven so it locks in place and close the oven cover. Close the splicer and press the oven start button. The oven will soften the protective sleeve and compress it around the splice, protecting and strengthening the splice. When the oven program is complete, remove the spliced portion from the oven. Slide the armored enclosure over the splice until it reaches the end of the cable jacket on the opposite side. Slide the cap up to the enclosure and screw it on hand tight. It's okay if some of the Kevlar fiber is captured in the cap threads. Hand tighten the cap at the opposite end. Use an adjustable wrench to tighten the nut between the cap and the enclosure. Then hand tighten the cap and use the slip-jaw pliers for final tightening, which grips the cable jacket securely and protects the splice from pulling forces. Repeat these steps for the opposite end of the enclosure. Operation Pigtail is now complete. Dispose of all waste properly and reorder any materials that have been used as necessary. Operation Clean and Polish uses the 0831 TAC 1000 Cleaning and Polishing Kit, which is also included in the Operation Test and Verify Kit. The Operation Clean and Polish Kit contains all the tools you need to clean and remove debris from ST and TFOCA 2 ferrules. To use the Operation Clean and Polish Kit, remove the contents of the pouch. Remove the clear plastic cap from the cleaning solution bottle and place it on the table with the open side up. This will be used to hold small parts during cleaning. Use the included screwdriver to loosen the captive retaining screws securing the insert in the TFOCA 2 connector. Remove the insert and place it in the clear cap. Carefully remove the 2 alignment sleeves from their ferrules and place them in the clear cap. Open the cap on the polishing solution and place the blue end of the connector cleaner over the hole. Tip the bottle so a small amount of the solution goes into the connector cleaner and soaks the material inside. Tip the bottle back upright and close the cap. Slide the blue end of the connector cleaner over one of the ferrules and push lightly until you feel resistance. The material inside the cleaner must be in contact with the ferrule end. Twist the cleaner 10 times in each direction, clockwise and counterclockwise. The polishing solution helps loosen and wash away dirt on the end of the ferrule. Repeat this process for each of the 4 ferrules in the connector. Select a square of lint-free wipe and press it onto the orange cap of the cleaning solution to deposit solution into the wipe. Wipe down all 4 ferrules to remove the polishing solution from the ferrule sides. Remove the dust cap from the clean clicker, but leave the orange adapter cap on the end. Slide the adapter cap of the clean clicker over each of the ferrules and press no more than twice to clean the ends. Use the red end of the connector cleaner to dry wipe the solution from the end of each ferrule, twisting the cleaner 10 times in each direction, clockwise and counterclockwise. Reinstall the alignment sleeves on the S1 and S2 ferrules by placing them with the needle nose pliers, then gently pushing down on them with the side of the pliers until they will not go down any further. To find the ferrules without markings, locate the 2 alignment pins in the end of the connector. With the smaller of the 2 pins at the top, the alignment sleeves are installed on the 2 ferrules on the right side of the connector. If an alignment sleeve is cracked or lost, replace it with one of the alignment sleeves from the kit. Reinstall the insert by matching the holes in the insert with the alignment pins in the end of the connector. Note, if the insert is installed backward, the small hole will ride on top of the large alignment pin, throwing the insert out of alignment. Be sure you have lined up the correct holes with their pins. Replace all tools in the 0831 TAC 1000 pouch. The 0831 TAC 2000 Operation Test and Verify Kit allows you to find the insertion loss values for connectors on TFOCA 2 reels and fiber runs. The kit includes all the tools you will need to perform this test: a laser and an LED light source and a power meter, a fiber check probe for inspecting connector ends, cleaning solution, lint-free wipes, a continuity tester for ST connectors, necessary adapters, the 0831 TAC 1000 cleaning kit pouch, and a set of reference cables. To use the Operation Test and Verify Kit, use the components in the 0831 TAC 1000 cleaning kit pouch to clean all connector ends before testing. Set up a light source and the power meter. For multi-mode fibers, use the LED light source. For single-mode fibers, use the laser light source. Turn the devices on. If you are using the laser light source, allow the unit to stabilize for 10 minutes before testing. Select the desired test wavelength on the light source and power meter. Perform a reference check over a single ST to ST measurement quality jumper, or MQJ, included in the kit. Connect the jumper to the light source and power meter. The meter will commonly show a very high or low number. To reference the power meter, press the REL button on the power meter. When you release the button, the meter should change to read 0. The power meter is now calibrated to the light source. To verify the 2 TFOCA 2 to ST reference cables, connect the TFOCA 2 connectors on the reference cables together securely. Disconnect the jumper from the power meter, but leave it connected to the light source. Connect an ST connector on one reference cable to the cable from the light source using a barrel connector from the adapter kit. Connect the corresponding ST connector on the other reference cable to the power meter using the following guide. When S1 is connected to the light source, connect P1 to the power meter. When S2 is connected to the light source, connect P2 to the power meter. When P1 is connected to the light source, connect S1 to the power meter. When P2 is connected to the light source, connect S2 to the power meter. If each of the power readings shows less than 1.5 dB loss, disconnect the TFOCA 2 connectors. Clean the TFOCA 2 connectors on the reel or cable under test using the 0831 TAC 1000 cleaning kit. Connect the TFOCA 2 connectors on the reference cables to each end of the reel or cable under test. Connect each of the ST connectors on the reference cables in the pattern shown previously and confirm that the loss is low based on the wavelength being used. If the power meter cannot be zeroed to the light source with the ST to ST cable, the cable may be faulty. Try the other cable in the kit. If any of the connections in the reference cable verification fails, clean and inspect the connectors involved. If a simple cleaning does not correct the problem, one or more of the connectors may need to be polished according to the 0831 TAC 1000 cleaning kit procedure. If any of the connections in a reel or cable test shows high loss, clean and inspect the connectors involved at each end of the cable and perform the test again. If the loss is still high, the cable may need to be tested using the Operation Pinpoint kit to find the problem.